I'm so pleased to introduce our next keynote speaker, Dr. Megan Franke, Professor of Education at UCLA. Megan's presentation today will further the conversation about supporting mathematical understanding and building upon children's strengths. Megan is the author of Choral Counting and Counting Collections, which you received this morning at the registration table. Please join me in giving a really warm welcome to Megan Franke.
Thank you, and welcome. And I want to welcome all the folks that are out in the online world out there, and I'm going to work really hard to invite you into our conversation today as much as I can. I have many goals for our conversation today, and I'm going to try and keep it as focused as possible. But one of the reasons why I'm really excited to be here is because there's tremendous momentum in the state of California around early childhood and early childhood mathematics. And one of my goals today is to talk with you in ways that help us build coherence in our efforts so that we are seen as working together to accomplish the goals in this state for young people and their families around mathematics, and that we don't come to the end of these awesome efforts feeling like we did 30,000 different things and didn't accomplish anything. And so part of my goal is to have many conversations where we can work together on what our goals are. Another part of my goal today is to have some specific conversations with you about what does it really mean to engage young people productively in mathematics in ways that Carolyn mentioned, build on their strengths, and take up the resources that they have. And so we've been doing lots of research about that, as well as engaging with lots and lots of educators around their practice, some of whom are in this room today. And so specifically, we're going to dig a little bit into counting to connect to the Counting Collections book that you all have in your bag. And so I'm going to refer to that at the end and help you know what's in there. But we're going to do some work together around counting. And the reason isn't because I don't think you all know already a lot about counting and think you know a lot about engaging young people in counting. I actually think you do it really well and do it a lot. And that's why I want to leverage it. And I want to leverage it to help support the resources that young people bring. And I want to tell you about some research we've been doing in that area. I also want to dip into this area in early childhood that seems to be a worrisome space for some of us, which is about asking young people to represent their ideas using paper and pencil, right? In preschool in particular, paper and pencil and writing things is a little worrisome. And I want to engage us in what that can look like and why that might be important. And probably the most important thing that I want to talk with you about today is this idea of partial understandings. And what does that mean for young people to notice what they know and to pick up the partial little bits of understanding they're starting to develop and use those in really productive ways? And that relates a lot to our first keynote this morning, where we're trying to think about the resources young people bring. They have lots and lots of understandings. We just don't see them all and don't notice them all because of how crazy classroom life is. And I want to help you look for those and notice those and leverage those. So let's get started. One of the things you probably heard me just mention is that, so a lot of the work I'm going to talk about comes out of cognitively guided instruction. And cognitively guided instruction started now 35 years ago in Wisconsin as a big research study. It's happening all over the country, but really what it's about is about listening to young people, knowing something about the development of children's thinking and leveraging that in ways that support young people. But probably the most important thing is that we're looking for what students do know, not what they don't know. So what is it that young people understand? It's very hard to build on what young people don't know. So in the talk this morning where we were hearing about how to build on young people's resources, we can look at a goal of how do you help young people learn to add and subtract to 20? Well, everybody knows something about that. We got to figure out what that something is. And I want to help you think about what that something is and know what to look for in that something, rather than saying they don't know it and we need to fill them up. Right? And to do that, we have to look beyond correct, incorrect, and understand the subtleties of young people's ideas. And that we need to see that young people not only have productive ideas, but they have productive ways of participating in mathematics, and we need to open up spaces for them to use those productive ways of participating. A lot of big talk. The question is, what does that look like, and how do we do it, right? So I want to work on counting a collection with you. And in order to do this, instead of bringing enough collections for all of us, I did put a collection on each table, but I don't want you to use it. And I want the folks, I want you first, and those folks who are not in the room, to dig into your pockets, your bags, and see if you got stuff in there that you could count. Do you have pennies, dimes, nickels? Do you got some cards in there? What do you have in those bags that you could count, you all? And at home, what do you got sitting around? Everybody needs to find something that they could count. What do you got, you all? All right, so I hope that you're using this as an opportunity to introduce yourselves to each other. Right? So make sure you know each other's names at your table. Will you just do that really quickly, you all? Make sure you know each other. Really quickly. You all are awesome. The stuff you carry around with you is quite impressive. So, here we go. This is what we're going to do now. So, essentially, in early childhood settings, we count things a lot. Right? There are lots of, just like that, things that are in your bags right now and in your pockets, in early childhood settings, there are lots and lots of things to count. And what I want us to think about is, what's the power in asking young people to count those things? And the task is a simple one. The task is, hey, can you count what's in your collection? And your job is a very simple job, which is to say, how many do you have in your collection? All of how this works is laid out in that awesome book you have in your bag, so I'm not going to spend a lot of time on it, but what I want you to do is I want you at your table to count your collection. You can do it with a partner, you can do it with your table, but here's the thing. Once you count it and organize it, leave it the way you counted and organized it on your table, and talk about what you think young people would need to know to count your collection. What do they have to know? So take like 3 minutes, you all. Count your collection, organize it, think about how many you have. That's your job. How many do you have? Let's regroup. Here we go. So, this is the danger of beginning counting collections, because it's kind of fun, you know, right? This is one of the things that we need to really remember about counting collections, is that we want it to be intriguing. We want young people to find it interesting. If you turn it too much into school math, you're going to lose the power of counting a collection of things, right? And just like you heard in your talk this morning, counting collections means everybody gets to come to it with whatever knowledge they have. I might be really good at organizing and sorting the collection. Somebody else might be really good at counting it. Somebody else may know how to count in the teens, but not in the 20s, but somebody in the group might, right? So the idea, and somebody in your group might be really good at navigating the social relationships that have to happen when you do one of these tasks together, right? So when we come to counting the collections, we all bring some expertise, some knowledge, some ways of participating that can enable the task to happen in a really natural way, right? So The thing that then becomes important for us mathematically, and I heard lots of you in this room doing a lot of different kinds of mathematics as you counted your collection, right? So people were putting things in groups, right? I saw things organized by color. I saw them organized by category of thing, right? If you're grouping, you're developing the beginning understandings of multiplication and division, right? That's where that starts. So young people they don't need to know that that's what they're doing, but that's the fundamental ideas they're developing there. Okay? So if you think about why do we want to count collections now that you've counted them, there's some really important ideas for us, right? One is they develop tremendous number sense. And one of the things that we found in our work is when I first moved to Los Angeles about 25 years ago, back to LA, because I grew up there, I went around visiting schools and I asked young people in the upper elementary grades to count for me from 80 to 120. Many of them couldn't do it, y'all. And it's not because they're not unbelievably capable. It's that we don't count in school very often. So think about it. If you don't count from 80 to 120, thinking about that, how that pattern goes, is not so easy. So where do you think they got stuck the most? 99. Okay, so some of it was 99, 100. Where was the other place? 109 to 110. Right? They could get the 1, 2, 3, 4, 5, 6, 7, 8, 101, 102, 103, 109, and then they didn't know what came after 109. Right? And so part of what really struck me was how little students in school have an opportunity to count and to count things, right? The same thing happens when they're not good at figuring out, well, geez, is it reasonable if I put 8 things and 7 things together, is it reasonable that my answer's 4, right? Like, because they don't have a lot of experience counting things, that's a really hard question for them to answer. And so these counting collections helps us work on all of that in a really natural way, as well as work on the counting principles. But it also takes up what young people knows and focuses on what they do know to help support their learning. And the important point I was making earlier is that there's something really important here about coherence and continuity. And what I mean by that is that if I start counting collections as a 3 and 4-year-old, and I do that same kind of work when I get to TK and K, I go in there saying, I know how to do this. I got it. I count collections all the time, right? And then I go from K to 1, and my first grade teacher's now counting bigger collections with other kinds of things, and I'm like, ooh, I know how to do this. I can count collections. So you're creating opportunities for coherence for young people. And you all know, if you work in early childhood education, how hard it is to help create that kind of coherence. We've tried lots of things to try and help students as they transition. But we know, for instance, right, when we can really improve young people's understanding of math in preschool, when they transition into TK and K, by the end of K, they all look the same. Right? And so we know if we can create coherence, that we're going to support young people to be able to continue to develop their math ideas instead of feeling like they're starting over every time they go to a new experience. Right? And counting collections and choral counting, which is in the book, are ideas of how we can create that coherence. Because we count collections with young people in middle school, in high school. You can count really awesome collections in really different ways and do a lot of math. So the task remains the same. The students see themselves as capable of doing it and bring new knowledge to that all the time. So I want to work a little bit on what do really young people need to understand to count a collection. And my guess is you all have seen this list quite a bit. So can you just turn and talk at your table? Do these things make sense to you? Do you have questions about them? These are the things that when we start counting a collection, and I'm 3, 4, 5, 6, 7, these are the things I'm working on. So can you talk at your table? Do these make sense to you? Can you say what each one is? Can you show with your collection what that would look like? You show people at your table. What does it look like to work on the sequence of number names? What does that look like? Finish up your conversations. We're going to regroup.
So here's the question. What's cardinality?
We're going to talk about that right now. Right now. All right, you all. So, often as teachers of very young people, we haven't had the opportunity to dig into these counting principles. The first ones are counting principles. We have in the resources we use often this notion that you need to know the sequence, right? You need to know the counting sequence goes 1, 2, 3, 4, 5, 6. You need to know those words. You need to know the order it goes in. And you need to know the order doesn't change, right? It's stable. It's fixed. That order stays the same no matter what. And that what you start to see is there is some structure to it, right? That it goes 21, 22, 23, 31, 32, 33, 41, 42, 43, and that structure helps you, right? And it's actually mathematically very important later. So you kind of have to know the counting sequence to count your collection. But could you have counted your collection without knowing the counting sequence? What would that sound like? I could go 6, 9, 3, 2, 4, right? Am I still counting?
You're using numbers, not letters.
I'm using numbers. So I may know some number words but not know the sequence, right? I may know some of the words in another language. I'm still counting, right? Counting in your native language is a really important idea, you all. It's really hard on your working memory to translate at the same time as you're counting something, right? So this is a space where letting young people count, even if you don't know their language, letting them count first in their own language is gonna really matter. But you need to work on developing the list of the way that we say the numbers and the sequence we say them in, but you don't have to know that to count your collection, right? You can get started no matter what. One-to-one correspondence is probably the one we work on the most and know the most about, which is every time you touch or one object, you only give it one number name, right? So when I touch the object, I say 1. I touch the next one, I say 2. I could also go 1, 1, 1, and name them all 1. As long as I give each one only one number name, I'm using one-to-one correspondence. Yes? Right? One object, one number name, I'm using it. But it doesn't mean it's the right number. It just means I gave it a number name. Okay? This idea that you got to count the whole thing. So if you're work with little young people, you've seen this probably where they say, I'm just going to count these and I'm done. Like I count these ones and I'm not going to worry about the rest. Because they don't realize that you have to count the whole collection to know how much is all there, right? That's work that we learn how to do in school or at home. So the one that we work on the least, probably know the least about, which came up a question over here, is cardinality. And what does that mean? And you may have heard it as the one way to, is the cardinal principle. Can young people use the cardinal principle? Using the cardinal principle means that when I count a collection, the last number I say tells me how many are in my collection, right? So if I am counting my fingers and I say 1, 2, 3, 4, 5, when I say 5, I know that means that's how many were in my collection. That's the cardinal principle. Understanding cardinality does a lot of things for us, which we can talk about on another day, but that really the idea is, can they use the cardinal principle? If they can't, I heard somebody say this, so like if they can't use the cardinal principle, you can see them go 1, 2, 3, 4, 5. Oh, how many fingers do you have? 1, 2, 3, 4, 5. Oh, how many fingers do you have? A lot of them. Right? And it's because they don't yet understand that the last number you say tells me how many you had in your collection. Do you see how sophisticated that idea is? Right? And as I mentioned earlier, because when young people count, and because the number system works in a particular ways, we group things in 10, right? They're also learning about grouping when they're counting, okay, in ways that are really fundamental for later. Oh, such a good question. Really good question. So subitizing means that I can look at a quantity without counting and know how many that quantity is, right? Cognitively, we can only subitize 2 or 3 things, right? Doug Clement talks about conceptual subitizing, which means that you learn that if it's grouped in a particular way, I can look at a group of 3 and a group of 2 and know that that's 5, right? Because of how my fingers are organized. Subitizing is, you can think about it as essentially a way to think about, so these folks, when they look at this and say 3, they know cardinality, right? They're using the cardinal principle to help them know that if I see this quantity, I already know without counting the number in my collection is 3, right? So in some ways, subitizing helps support or is working on that idea of the cardinal principle, right? Okay. And they will start like looking at the 2 first rows of those bears and know that that's 6, because I know the first is 3 and the second is 3. So I know that that's 6. But really, subitizing itself is around looking at 2 and knowing it's 2, looking at 3, knowing it's 3. OK, so what I want to do is to say, all right, that's the stuff they're working on. How do we notice what they do know? I want to practice looking at what do these young people know. So your job, I'm going to show you a series of videos. Your job is to identify what the young people understand as they're counting their collection. So we're going to start with FINA, and she's 3.
Okay, FINA, how many rocks are there?
1, put one right here. 2, put 2 right here. 3, 4, 5, 6, 7, 8.
How many are there?
There are a lot.
Could you give me 5 rocks?
Yeah. There's 5. Here, 5.
Did you give me 5?
Mm-hmm.
Can you double check that you gave me 5?
5 and 5 and 5.
Right. Thank you.
OK, so one way to interpret FINA, if all we were looking at is did she get the right answer, would be she can't count. What I want you to talk about is what does she understand? You have a minute at your table. What does she understand about counting, you all? What does she understand? Here we go. All right. So, FINA. So, given the conversations I'm hearing, I'm thinking you're going to say that FINA knows some stuff about counting. Yes? So characterizing her as not knowing would be really problematic. What does she know about counting, you all? What does she know? She had one-to-one correspondence, right? For every rock, she said 1 number word. So that's a really important idea. What else does she understand? She has the number sequence to what? What does she get to? 7 or 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay, really nice. She repeats it, so we get to hear her. What else? She's got a nice way. So I'm going to put this one here, and I'm going to put this one here, and I'm going to put this one here. So she's thinking about how to organize her collection. What else?
She's developing. Because once she separated rocks, she didn't count one-to-one correspondence.
Yeah.
But she's starting to develop.
Yeah, so this is a really nice point, right? She's developing her one-to-one correspondence. These are not all or nothing constructs, you all. And if you work with young people, you see this every day, right? We think they got it, and then you give them something else to count, and they show something else. And it's not because they forgot. It's not because they didn't pay attention. It's because developing one-to-one is a really sophisticated idea. And with different collections and different contexts and different questions, you're going to show different kinds of knowledge. And so what you see when Angela says to her, can you give me 5? Right? So that's a way to find out, can she give you a set of things, right? Kind of like the working on the subitizing idea. So can she give you 5? And she just grabs a bunch. She knows it's more than 1, right? Like she doesn't give her 1 rock, she grabs a bunch, you all, and puts it in her hand. And this is what I mean by noticing the subtle things they're doing that tell you something really important about their understanding, right? The fact that she gave more than 1 tells you she's developing some really important ideas right there, right? And she knows there's supposed to be 5 in that hand. So she's gonna make that work. When Angela says, so how many, are you sure there's 5? She's like, yeah, I'm sure, 5, 5, right? 5. And I think it's Rachel, is that? Rachel made a really helpful point for me as I was walking around, which is that we have to really work on how we listen to young people so they tell you all those subtleties. If they think we just want to know, did you get it right, you're not going to get to hear all of that stuff that you got to hear in there, right? Like, how do we do it in a way that we're not portraying judgment, that we're not portraying like, oh, crap, you don't got it yet, right? It's hard to do as a teacher. And so working on this idea that really what we want to hear is all that cool stuff that doesn't quite sound right, but it's actually mathematically really important. That's what I want to hear from you, right? Okay, can we watch another one?
Yeah.
All right, here we go.
You're in a room full of people who like watching.
I know. It's fun, isn't it? Okay, this is Lily. I think I can just do this.
How many are there? How many bears are there? You want to count them to see if we can find out?
One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 14.
How many bears are there?
14.
Can you do that one more time again for me?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 14.
How many bears?
14.
All right, you all.
How many green bears do you have? Do you know which ones are green? How many green bears are there?
1, 2, 3, 4, 5, 6.
How many green bears?
6.
All right, what does she know? You got 30 seconds. What does she know? What does she know? Okay, so what does she know? What does Lily know?
1 to 1 to 6.
She can use the cardinal principle. She does it every single time. When you ask her how many, she tells you the last number she said, right? With the 14 as well as with the 6 green bears, right? What else does she know? She has a way to group them, starting to think about grouping by color, right? She can pull out a group of 6 and count that group of 6. What else is she understanding?
She can roughly count 12.
She knows to count the whole collection, right? Somebody said something else, I didn't hear it. Yeah, she's organized, she's working on how to organize. And actually, when she doesn't organize, she counts just fine, you all, right? Like when she's got that group of 6 bears in front of her, it doesn't, you get worried, like line them up, but she counts those really well, right? You said something different.
She rotely counted to 12.
She rotely counts to 12, you all, right? She knows the counting sequence all the way into those messy teens, right? And she's developing one-to-one correspondence because she uses it a lot. She just doesn't use it all the time, right? And so we get to see her emerging, developing ideas of one-to-one correspondence. Right? So do you see how when we see her as somebody who has all of these understandings, that it changes how we think about what to do next, right? Because it's not about fixing her, it's about creating opportunities where she gets to develop these ideas a little farther, right? And you can give all of these young people collections to count with partners and let them work together no matter how much understanding they have. Everybody gets to do the same task and work on their own sets of understandings, okay? So there are lots of videos, but I gotta skip them because I'm way behind schedule, because I wanna show you some data, you all. And the data that I wanna show you is, so we had the opportunity to talk to 435 3- and 4-year-olds. Mostly 4-year-olds. It was awesome, you all. If you're having a bad day, Go talk to a 4-year-old about math, because it's just fun. We gave some really traditional tasks that are given on almost every assessment. The really common one we give is how high can you count? When you pause, we say, ooh, can you keep going, right? We prompt you a couple times to see how high you can count. We line up 8 bears. This is also a really common task. You line up the bears for young people and you ask how many, right? All the same color. And then, good old us, we gave them a pile of 31 pennies, literally a pile of 31 pennies, and asked them to count for us. Okay? These are 4-year-olds. Wouldn't necessarily expect them to be able to count 31 pennies. Okay? But what was interesting about what we learned is that our traditional notions, or my traditional notions, and some of the literature's traditional notions of how counting develops were pretty challenged in this data. These were young people across Los Angeles and broader Los Angeles, but 41% of the children counted higher, the counting sequence, higher, when they were counting the pennies than when we said, count as high as you can count.
That seems backward.
This is counterintuitive, you all, because when you're counting pennies, you're coordinating activity, right? You have to count and keep track of the pennies and do one-to-one correspondence and cardinality. Like, you got to do all those things. When I say just do the counting sequence, we think of that as a simpler task because we're just asking you to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So why would they count farther on the pennies task than when we ask them to count out loud? Talk to your neighbor, 20 seconds. Why? Why? All right, here we go. See, I meant 30 seconds, really fast. Okay. So, here we go. Here we go, you all. So, I cannot tell you why, but I've heard some really good hypotheses in this room today, and hypotheses that we have also been thinking about. One, which is the counting of the pennies is unbelievably motivating. Like, you want to get through the pile, right? And so as you're counting, you just keep going. And even if sometimes you don't realize you can count farther, right? Like, you just keep counting. And so what happens, right, is young people just make up words, right? Or they count the sequence over again because they don't know what comes next, but they really want to count the whole collection. And because of that, you get to hear lots of things they actually know, right? You get to hear them go, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15, 17, 13, 15, 17, 13, 15, 17, 13, until they finish, right? So you get to hear all that they know about counting when you give them these 31 pennies, right? And there may be something really important in the movement, you all. Like, they're moving the pennies, and it's helping them count as they go along, right? That it's supportive. So rather than thinking about this coordination activity as making it harder, I think we need to think about how this coordinated activity actually supports them to show you what they know. And that we're way underestimating young people when we just say count as high as you can count, right? Because more kids counted higher on the pennies task than they did on the count out loud task. All right, another one. It's also true that children who didn't use one-to-one correspondence when counting the 8 bears, so this is supposed to be easier, right? I lined up 8 bears for you and I said, how many do you have? There were kids who did not show one-to-one correspondence on that task, but did on the pennies task. They had to move and organize in a way that makes sense to them, right? We think that lining up the 8 bears is going to make one-to-one correspondence easier, but like, you watched, Lily, like getting your little finger on each of those bears in a way that you get them all is not necessarily an easy task. It's also the case that on the pennies, we got to see, so some kids would start with one-to-one and lose it really quickly, and then as they got into the pennies, they got better at it, right? Because they got into a rhythm of going like this, right? And so sometimes you stumble at the beginning, so if you only look at their counting of 8, you're gonna miss their understanding of one-to-one correspondence, okay? All right, I have one more. It's also true that 15% of the young people who did not use the cardinal principle on the bears task with 8 used it on the pennies task with 31. It doesn't mean that they said the right number, but when they finished counting their pennies and I said, how many do you have? They told me the number that was the last number they said. So, yikes, right? Like, the question then becomes, so what does this all mean, you all? And here's what we take from it, right? That young people have lots and lots of important understandings that aren't all or nothing, like you all said, and that the tasks we use sometimes don't help reveal the understandings that they have, right? And that it's not about can you use one-to-one correspondence perfectly in this setting? It's what are all the ways in which we get to see what do you understand about one-to-one correspondence? And that it really varies across tasks, right? And so we gotta be careful about the assumptions that we make about what young people understand based on one task. And I would argue based on a really formulated small task, that we learned way more on Count 31 Pennies than we did on any of the traditional tasks that we tend to use. And so we hesitate to go bigger. Yeah, no. Go bigger, people. Let them count bigger things. The other thing that I want to say, which is also counter to what we have been thinking, is that in a lot of the preschool curricula, we say, teach the counting sequence first. Once they have the counting sequence, then let them count things. Only let them count things up to 5, work on one-to-one, then work on cardinality. We had young people, like we saw, right, with Lily, who knew the cardinal principle and could use it really well, but was still doing a lot of work on one-to-one correspondence. These things don't happen in the same order for all young people. Some people are really good, young people, because of their experiences, are really good using the cardinal principle. Other young people, because of their experiences, are really good at one-to-one correspondence. Others are good at the number sequence. They don't happen in order. So if you say to young people, you have to count the number sequence first before you get to count a set of things, you are not giving young people an opportunity to develop their mathematical understandings because you're ignoring the fact that actually counting things is going to help them learn the number sequence. Make sense? All right, really quickly, turn and talk about these ideas to each other. You got 30 seconds. These make sense to you? What do you think? So I'm not going to spend any time on this slide, but I want to put it up there for you because what we've been doing over these last few minutes is trying to capture the important, really, really important partial understandings that young people have. I don't like this idea partial. I termed it. I don't like it because it makes us think that it's limited, right? And what I'm instead trying to communicate is these partial understandings are mathematically powerful, you all. They're really important mathematical ideas. And usually we take young people who have a little bit of knowledge and we kind of marginalize that as not knowing. And I want you to take those ideas and say, if you're organizing your collection, you're doing hugely important mathematical work. Even if you can't use the counting sequence or know one-to-one correspondence, that's hugely important mathematical work. And what that does, changing that, helps us really create openings for students to build their mathematical understandings, to feel competent, right? We can't just make kids feel competent, right? We have to create situations where they get to actually be competent. Right? And we get out of that binary of you know, you don't know, you know, you don't know, right? And really dig into the details. Our experience is that teachers of young people are really, really good at it, doing this work, paying attention to partial understandings. We just don't give them the openings and freedom to do that. And so we gotta let that go and let teachers really get to know their young people. So why does this matter? So this problem is one we pose to lots of kids. 19 children are taking a minibus to the zoo. For those of you who heard me give this talk before, or a talk like this, It used to say 19 children are taking a bus to the zoo. I wrote the problem. When I gave it to 5-year-olds, they said to me, you can't take a bus with 19 kids, you have to have 50. Which is true. In our state, that was true. You don't get to go on a field trip in a big bus with 19 people. So I changed it to a minibus, and they were happy. I don't know what a minibus is, but it sounded like it wasn't a bus. And we laugh at that, but context matters, you all, right? The whole point of posing a word problem is context is supposed to help you figure out what to do, not make it harder. So if young people are paying attention to the context, that's exactly what we want, right? So they're taking a bus to the zoo. They have to sit either 2 or 3 to a seat. Yeah, that's probably not legal either. The bus has 7 seats. How many children will have to sit 3 to a seat, and how many can sit 2 to a seat? Imagine in your mind with your counters, like we could do this, but we don't have time, how little people are going to solve this problem. So it turns out 59% of the kindergartners we talked to had a correct strategy for solving this problem. Pretty awesome, right? What do you think they did? They did what the problem said. I got my 19 children, I got them out, right? I got my 19. And then I said, hey, it says they have 2 or 3 to a seat and there's 7 seats. I can start passing them out to seats. I can do that. I can make my 7 seats and I can put 1 on each seat and pass them out till they're all gone, and then I get to see. If you do what the problem says and you got some tools to do it with, 59% of the kindergartners could do that, right? Here's the more worrisome part. So 51% of those 59% had the right answer too, right? Only 33% of the first graders and 26% of the second graders in the same situation with the same numbers got that right. They're getting worse as they're getting older. Why? Well, you got 30 seconds. Why? Why? Why are they getting older? The title of that slide is, right, we're not taking up the varied resources that young people have. We're not letting them make sense of mathematics in ways that work for them. We're saying, do it my way, right? Do it my way. Do it the school way. And one of the things that's really hard for teachers of young children is how do we transition from counting things to problem solving? And I want to pose a way for us to build on and use the young people's resources.
Yeah, nice. You're right. So can we figure out how many bears we have in this collection?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Nice job. So when I know you told me that you had some green bears. How many green bears do you have?
1, 2, 3, 4, 5, 6.
Nice job. How many red bears do you have?
1, 2, 3.
Do you have more green bears or more red bears?
Green bears.
How do you know?
1, 2, 3, 4, 5, 6, and 1, 2, 3.
So how do you know the green bears are more?
Because 6 is higher than 3.
Nice job.
Because 6 is higher than 3, he said. So in this setting, he counts his collection. He understands it. He knows how many were there. And then I get to pose a problem, right? I get to say, hey, you said you had some green bears. How many do you have? You said you had red bears. How many of those? Because when I was first showing the bears, he said, oh, you have green bears, red bears, yellow bears, right, in the cup. And I said, you said you had red bears. How many do you have? And then he got to reason. I get to ask him, how many more green bears than red bears? Right? You can take a collection that you counted and pose a story problem based on the collection that they understand and help them transition from counting to problem solving. Can you quickly take one of your collections and think about a couple different kinds of questions you could ask of your collection? What could you ask? So this was a compare quantities, but what other kinds of questions could I ask? What else could I ask, you all? What could you do? I apologize for moving so quickly here. We need to finish up. But so we can ask, what happens? We have one where I think Nick asked, what happens if your green bears got up and walked away? How many bears would you have left, right? You got action there. Those bears are leaving. How many are left, right? I can say, hey, what if I gave you 2 more bears for your collection? How many would you have now, right? I can join. I can separate. I can also say, what if we wanted to share the bears so we both had the same amount? Woo-hoo, right? They can share the bears. They're good at sharing bears with people. So one of the things that I want you to think about today is, as you think about counting collections, the power of it, yes, is in counting collections and really thinking about all the math that goes with that, but it's also the space in which problem solving is emerging. Young people are solving problems and can solve lots of sophisticated problems when they're counting a collection. And the beauty of that, right, is that when I've already counted it, I understand something about the collection. So you got some scaffolding in there for young people, and that you're really helping them see this isn't new math, you all, right? That we didn't just finish counting and now we're working on to adding and now we're working on subtracting and now we're going to multiply. This is all doing math, right? And so I get to use all of those varied resources that I have to help me do math. Okay? So I'm going to skip a whole bunch of slides, and I don't know how to do this, but just so you get to see, we were going to work on representation. So one of the things people really worry about is asking young people. So what we do is we say to young people, can you show me how many were in your collection on this piece of paper? Can you just show me how many are in your collection, right? So imagine this. Does this surprise you? Right? I take my collection, I put it right on the paper, and I trace every single one of them so I can say this is what's in my collection, right? I pick up one, I make a circle, right, on my paper. I pick up one, I make a line. There are lots of ways in which young people can record how many are in their collection. Right? Representation is a huge part of mathematical work. Some young people are really, really good at representing. And that provides them power, right? It provides them opportunities to show you what they know. So I want to really encourage you to really think about asking young people, can you show me on this piece of paper how many are in your collection? They're going to surprise you, promise. And you're going to get things that look like this at the beginning, right? Can you see that? This is one student over the course of a year in preschool. How cool is that? Oh, that's new. Okay. We're going. So here's what the last thing that I want to end with is that my colleagues who've been working on this work have been talking with a bunch of folks across the state, some of whom you've heard from today, who are all engaged in initiatives around early math in the state of California. And one of the things that we really want to try and do is to think about how we make explicit what our stance is. So we all, even if we're doing it we're working on it in a little different way, we all agree this is what we're trying to accomplish. So I have 2 slides I want to show you, and then I just want you to do a turn and talk. So our stance is really guided by these principled ideas. Young children, no matter what their age or background, bring with them diverse cultural and linguistic resources and robust mathematical understandings to learning situations. Number 2, the role of early childhood educators and care providers is to build on children's intuitive ideas about math, drawing upon the resources that children bring as productive learning supports. This can occur in powerful ways across a range of informal and formal spaces in playful, intentional, and developmentally appropriate ways. Try not to get rid of play, right? Attending to the details of children's thinking through the lens of research-based principles supports teachers to recognize what children understand and to make instructional decisions that build from what they know and can do. Mathematical identity, you heard about this already today, right? Mathematical identities are socially constructed by us in ways that privilege and marginalize some groups of people, and that we need to challenge that, you all. We need to recognize that that when we position some kids as good at math, you heard this morning too, and other kids as not, right? We're just creating inequity, right? And our job is to disrupt that a little bit. The deep mathematical learning occurs through multiple modes of communication: spoken language, gesture, movement, tools, and written representation. This came up earlier when somebody in the group said, hey, we gotta really make sure we're talking about dual language learners all the time. Early childhood educators and care providers are professionals with vast experience and knowledge, and that they should be supported to try new things, to innovate, to reflect, as these processes are critical to long-term learning. We often position as teachers of young people as not knowing anything, you all. They're unbelievable. You all are unbelievable, and that we need to acknowledge that. So we're done, but can you do a quick turn and talk about these ideas? Do these make sense to you? Are these the ones that you think about when you think about the work you do around teaching and learning of mathematics? Really quick. Got 1 minute. These make sense? Anyone surprise you? All right. So I'm hoping that those principled ideas stimulate lots and lots of our conversations. I want to go to these resources. So in your bag, thanks to the folks who put on the meeting, you have the Choral Counting and Counting Collections book. In there are chapters written by teachers about the work they do. So there's a preschool teacher who's writing about her work using counting collections in a dual language setting. So you get to see it and hear it in English, and it happens to be Spanish-speaking setting. There's also resources on the Dream Teacher Ed website for people who are trying to help prepare preschool teachers and early childhood teachers around math. There are videos of our teachers on the teaching channel doing this work with young people in both English and Spanish. And then there's a couple of other books that we've written about children's thinking that also help support these ideas. So lots of resources out there for you to draw on, just like we heard this morning. It's just hard to know what to do. So I hope today gave you some ways to think about what to do next, you all. Thank you.